Hello friends, today we are going to start with the third chapter, which is the last chapter from Unit 3. The chapter name is Natural Language Processing. So in this particular video, let us see what is NLP basically and what are the different phases involved in NLP. So usually the humans communicate using natural language like English, Hindi, Marathi, Konkani and so on. Every language has a well-defined syntax, rules, these are called as grammatical rules, and part of speech categories like nouns, adjectives, adverbs, and so on, which basically help an individual to derive meaning out of the given written or spoken sentence. However, machines understand the language of only zeros and ones. So the problem here is how a machine can be made to understand the natural language with which humans communicate, right? So the process of making machines understand and process the natural language is one of the most difficult tasks so far. Then what is NLP? Natural language processing is basically a subfield of linguistics, the study of languages, right? Computer science, information engineering, and artificial intelligence, concerned with the interaction between computers and humans, that is, natural languages, in particular, how to program computers to process and analyze large amount of natural language data. So NLP is basically a subfield comprising of many multidisciplinary uh, fields. Okay, the main aim of this is how computers can be made to communicate and interact with humans with their languages, with the natural languages. Now there are two components of NLP. The first component is called as natural language understanding, or NLU. Understanding basically involves the following tasks. First, mapping the given input in natural language into some useful representations. Because whenever an input is given from the human side, a high level natural language, machine has to represent it in internal representation. So that's the first step. Mapping the given input, which is given from the human side, to the machine. Now this input is in natural language into some useful representation so that machine can adjust. And second, analyzing the different aspects of the language, right? Once a particular representation is given, okay, a machine should analyze different aspects of the language, maybe the part of speech or maybe which are the objects involved in it, to and try to understand. So this is basically natural language understanding. The second component is natural language generation. And this is the other way around process. Now this generation is from the machine side to the humans, right? So it is a process of producing meaningful phrases and sentences in form of natural languages from some internal representation. It involves text planning. Now what is this text planning? It includes retrieving the relevant content from the knowledge base. So everything would start by retrieving the content from the knowledge base. So that is text planning. Then there is sentence planning. This involves choosing right words, forming meaningful phrases, setting tone of the sentence. Okay, so this is the second thing in natural language generation. And third, text realization. It is mapping of a sentence plan into the sentence structure. Okay, so text realization is mapping of the sentence plan into sentence structure. So this is natural language generation process. Now let us see what are the difficulties in natural language understanding. And when I say natural language understanding, it is not from the human side, but what are the difficulties faced by a machine who is now capable of understanding the natural language. What are the difficulties associated? Okay, first, natural language is, it's extremely rich in form and structure. However, it is very ambiguous. There can be different levels of ambiguity here. The first is called as lexical ambiguity. It is at a very primitive level, such as word level. For example, treating the word bored as a noun or as a verb. Because we know that in English, in natural languages like English, a certain word, when it is used in a particular context or in a particular sentence, it could be a noun. Whereas in some other context or in some other word sentence, the same word may appear as a verb, right? So this is a lexical ambiguity that is possessed by the machine side, from the machine side, whether to treat the particular word as a noun or whether to treat it as a verb, or and so on. So this is lexical ambiguity. Second is syntax level ambiguity. A sentence can be parsed in different ways. For example, suppose the sentence given from the human side to the machine is, he lifted the beetle with red cap. Now, from the machine side, the difficulty in understanding the sentence is that whether he used the cap to lift the beetle is right, or he lifted a beetle that had a red cap is right. Because when I say with the red cap, does this mean the person lifted the beetle with an object called as red cap, or whether he lifted a beetle who was wearing a red cap, is not understood by the machine. For you and me, this could be obvious, but for machine, nothing is obvious. Third kind of difficulty is called as referential ambiguity, and this is very common. Referring to something using pronouns. For example, say Rima went to Gauri. She said, I am tired. Right? The first sentence is Rima went to Gauri. She said, I am tired. Exactly who is tired? How machine will know? Because whether it is Rima or Gauri. In the previous sentence, there is an object called as Rima as well as Gauri involved in the sentence. Next sentence is, she said, I am tired, right? Now you and me will understand that since Rima went to Gauri, here also there is a confusion, because you really can't make out whether Gauri said she is tired or whether Rima said she is tired. And the same difficulty is, from the machine side. This is called a referential ambiguity. Reference. One input can mean different meanings, right? The one input can mean different meanings. For example, okay, suppose the sentence is, this mobile is very heavy on my pocket. Okay, now if you take the literal sense, that means the mobile phone, with respect to the weight, it is very heavy, right? But in the actual sense, it really means what? It means that heavy on my pocket, meaning this mobile phone is very expensive for me to spend money from my pocket, right? So that means one input sentence can have different meanings. What is important is, how do you treat that particular sentence? What is the right way of understanding that sentence? Okay, that is another ambiguity. Also, many inputs, they mean the same thing. Okay, for example, you have so many sentences, for example, wherein murder is there, kill is there. Now we know that both things are same, but for machine, he has to be told about all these things, right? Difficulties in NLP. Now, what are the difficulties associated with natural language processing? Not with understanding, with processing. The first and foremost difficulty is that English sentences are incomplete description of the information that they are intended to convey. Okay, the English sentences, they are incomplete description of information they are actually intended to convey. For example, let us take a sentence. Some dogs are outside. Okay, now the problem here is, does outside mean outside the room? Okay, or does it mean outside the house, or does it mean outside or on the garden lawn? What does actually it means, right? Thus, if there is another sentence, okay, so the problem is whether it means outside the room, or whether it means outside the house, or whether it is garden lawn. Suppose there is another sentence that we consider, say the three dogs are on the lawn, right? Just check in the previous sentence. The sentence was, some dogs are outside. A generalized sentence wherein I don't know how many dogs and I don't know the exact meaning of outside. Now there is another sentence, a kind of specific sentence now, which says three dogs are on the lawn, right? Now you and me as human beings, we can easily say that this is a generalization for this particular specific sentence. But for machine, he will have to really find out, is this sentence equivalent of the more generalized sentence that is given above? Will machine be able to find out this? This is a difficulty. Okay, this is one problem which machine has to solve. Okay, in fact, the programmers who are working with NLP will have to solve this, right? This is one of the difficulties in NLP. Next, the same expression means different things in different context, right? For example, where is the water? Suppose this is a sentence. Now, uh, if the context here is a chemistry lab, okay, then you know that the water which I am talking about here, it must be a pure water, right? But suppose the context in which the sentence is used is a leaky roof. There's a leakage on the roof because of rain. Then you can say the water can be filthy, right? So water, the word water is same, but with respect to different context, the meaning of the water becomes different. I mean, type of water is different. The first case, water was a pure water. In the second case, it was a filthy water. Water is same, but the properties do change, right? So, can the machine make such inferences? Okay, this is also another challenge that is posed by NLP, natural language processing, right? Now, let's move on to the third problems or difficulties. No natural language sentence can be complete because new words, expressions, and meanings can be generated quite freely. Okay, today we are in the era of WhatsApp, so there's a common term that we use. Okay, I will WhatsApp you, right? But if you consider this sentence maybe some 20 years back, when hardly people used to use internet, okay, and if somebody had said this sentence 20 years back, do you think the sentence would be relevant? Would you have been able to understand the meaning of what is WhatsApp? No. So that is what it means. Today we know that there is something called as WhatsApp. So the word WhatsApp has come. Okay. Similarly, in Facebook, now we call it as post. Earlier we used to call it as scrap. Right? I have written a scrap on your wall. Right, now we use the word post on the wall. So as the technology changes, as the years pass on, okay, new words and new expressions, okay, and new meanings, they can be generated quite freely, right? As a result, for machine to keep track of every day's new additions in the lexicon of English, and to utilize it for its processing becomes very difficult. So this is the third and the most important difficulty. Let's take an example. I'll fax it to you. If this is the word, this is a sentence, right? Now, machine would not know the meaning of this sentence if it cannot interpret that I'll. This is just a style of writing, the short form. If machine cannot interpret I'll being the short form of I will, if it does not know that I'll actually means I will, then it will not be able to know the meaning of the sentence. Also, if the machine does not have a word fax known to it, because fax is using a fax machine and sending some data, that's the meaning of fax. But if machine does not know the word called as fax, then this sentence would be difficult to understand for the machines, right? So this is what it means, third difficulty. Okay, please make note, the number here should be 4. So the fourth problem posed by this particular thing is, there are a lot of ways to say the same thing. Okay, as I was talking about earlier, the same thing can be said in many different ways. For example, Mary was born on October 11th. If this is a sentence, okay, is this sentence same as the next sentence, Mary's birthday is on October 11th? Now we know that actually it means same. If somebody is born on a particular day, that means that person's birthday is on that day. But will the system be able to deduce this like how we humans do? No. So there should be some representation that should map these two sentences as equal. So this now, how many such sentences are you going to map? Okay, how many such sentences explicitly are you going to tell the machine? So this is the third difficulty that is faced with natural language processing. Okay. Now we'll see the features of natural language. I'll just list down. Uh, First feature is it allows speakers to be as vague or as precise as they like. It allows speakers to live out things as they believe their hearers already know. So the first feature of natural language is that you can be as vague as possible, or you can be as precise as possible while speaking. Okay. Also, natural language that you speak usually, it allows you to leave out certain things which you believe the hearer must be already knowing, right? But because of this particular feature, okay, a machine which is there, okay, gets confused. Machine would not know a generalization, how to map that generalization to a specific sentence if you have not programmed it that way. Now, the second feature of natural language is languages let us communicate about an infinite world using finite number of symbols, right? Third, language can evolve as the experiences that we want to communicate. And when you know a lot, facts imply each other. The language is intended to be used by agents who know a lot. So these are some of the features of natural languages, that is English or Marathi or Hindi or whichever other language. Now, the last thing that we are going to see in this particular tutorial, okay, is the components or steps in natural language processing and understanding. What are the different steps or components in natural language processing or understanding? Now, the very first process is called as lexical analysis, which is also called as morphological analysis. Okay. After the lexical analysis, okay, after processing the given English or natural language sentence, it is given to the second process that is called as syntactic analysis. Syntactic analysis has got something to do with the syntax or the representation of the sentence, the rules. Okay. Then from syntactic analysis we go to the semantic analysis, wherein we are trying to deduce the meaning of the sentence, whether the meaning is correct or not. From here, the next phase is called as disclosure integration. I'm sorry, it is called as discourse integration. It is misspelled over here. It is called as discourse integration. And discourse integration basically involves with connecting different sentences and finding out who has actually said a particular thing. Suppose the sentence is John has purchased a car. Okay, he always wanted to purchase it. Now in the second sentence, when we say he, the mapping of he should be with John. Similarly, he always wanted to purchase it, the mapping of it should be with car. Okay, so this particular sentence can be generated based on the previous sentence, and so on. So this is basically discourse integration. And last is pragmatic analysis. It's a method wherein it's a process wherein when the sentence can be said in multiple things, okay, getting the correct meaning of that sentence, that's a pragmatic analysis. So these are all the components of NLP. Let us see in detail each one of them. So as I said, the first phase of the natural language processing or first component is called as morphological analysis, or it is also called as lexical analysis. Okay, here the individual words are analyzed into their components as non-token words such as punctuations, and they are separated from the words. Okay, morphological analysis is a particular is a process wherein in a sentence, whichever words which are there, okay, we are going to distinguish them as tokens and non-token words. Okay, basically these non-token words are nothing but commas, uh, exclamation mark, question mark, quotes, okay, or semicolons. All these are called as non-tokens. So such non-tokens have to be first removed from the given statement, and the valid words which are there, they are called as tokens. So the process of removing the non-tokens from a sentence, which is called as tokenization, okay, is one of the pre-processing steps of natural language processing. So morphological analysis basically is involved with removing of these non-token words from the given sentence. Okay. Now, if the sentence is, say, I want to print bills.init file. Now here, once the sentence is tokenized, you know that apostrophe will go, quotes will go, and dot should also go. But understand that when I say I want to print bills.init file, I think dot has to be retained. Why? Because when I say .init, the machine will know that this is an extension to a file. Okay, so the machine will then realize that when I say I want to print bills.init file, it is that particular file whose extension is .init. So here dot should be retained. Okay, so morphological analysis of the above sentence, it basically does the following. First, it will pull apart the word bill apostrophe s into a proper noun bill and the possessive suffix s. So apostrophe after it is removed, this word will be a proper noun which is bill, and s will be a possessive suffix s, and apostrophe will be removed. That's the first thing what it will do. Second, it will recognize the sentence .init as an extension to the file that is functioning as an adjective in the sentence, and as a result, dot will be retained, it will not be removed. Even though it is a non-token, it will be retained. Why? Because that dot helps you to understand that init is a extension. .init is an extension of a file. If I don't write dot, it could just mean that init is the name of the file, which is wrong. Okay. Further, each word in the sentence is assigned its syntactic category, like noun, verb, adjective, and so on. So each word in the sentence will be assigned its syntactic category, right? Now once this is done, the next phase is called as syntactic analysis. So in this, the linear sequence of words which we have in the previous step, which are output from the previous step, are given as input here, and that linear sequence of words are transformed into structures that show how the words relate to each other. Okay, now some word sequences, they may be rejected if they violate the language rules for how words may be combined. Okay, for example, English syntax analyzer would reject the following sentence: the sunny weather nice, right? Because if you see the placement of words here, according to the English grammar, according to the language rules, this is not how the sentence can be framed. So although the individual words are correct words in English, but they are not placed correctly, so this is syntax error. So syntactic analysis will find out such kind of sentences, and ambiguous sentences like this will be noted down. Okay. Now grammatical rules in English, for an instance, I have just taken example of that one sentence. I want to print bills.init file. So with respect to it, now this representation is called as Backus-Naur representation. Okay. So grammatical rules in English example are as follows: a sentence can be a noun phrase or a verb phrase. Any sentence can be either a noun phrase or a verb phrase. Then verb phrase is nothing but it can be a single verb or it can be a sentence. Okay. Verb phrase also can be a single verb or a noun phrase itself. Now what is noun phrase? Noun phrase can be a pronoun, or it could be an adjective, or it could be a noun phrase. pronoun I. That means I is a pronoun. Noun, say, now there could be so many nouns, but I am saying that file is a noun. File is a noun because I am referring to only one sentence. Which sentence I want to print bills.init file. So I will be only considering the words which are there in this sentence. Otherwise, this list should be very extensive. Okay. So n or noun is a file. That means file is a noun. Now, what are verbs? Want, print, these are the words in that sentence which are nothing but verb. And what are adjectives in that particular sentence? .init or bill apostrophe s, bills, these are all adjectives. So these are the grammatical rules in English. This is how they are written. Okay. Now, suppose I want to find out, I want to determine the parse tree for the sentence. I want to print bills.init file. Then how would I start? These are the particular English representation, Becker's knot representation. So basically, when I see in ALC subject also we have seen all these things, parsers, parsing, right? So there are two types of approaches, top down and bottom up. So I will show you a simple top down approach. Okay. So top down derivation it is called as. Now S is the start symbol of the production. This is the right hand side of the production. This is the left hand side of the production. So this is basically a grammar. If you remember your context free grammars in ALC, right? So now let's try to map this particular sentence. In top down parsing, what we do, we start with the start symbol, and every time now we will try to replace the left hand side with right hand side, and finally if you are able to get the entire sentence, then you say that the sentence belongs to the language, otherwise the sentence does not belong to the language. Just a recap of what we had studied in ALC, right? Now let us parse this sentence. So since we will start with the start symbol, it's a top down derivation, so let S be the start symbol. Now S can be replaced with either noun phrase or verb phrase. So S can be replaced with noun phrase or verb phrase. Now what I want is I, correct? The first thing which I want to map is I. Now what is I? I is a pronoun, right? Whereas pronoun in turn can be a noun phrase. So I can use, noun phrase can be a pronoun. So I can use this rule. So noun phrase can be pronoun. And further I can say pronoun can be I. Correct? Similarly, verb phrase, if you see, verb phrase can be a single verb or entire sentence, or verb phrase can be a single verb or noun phrase. So I replace noun phrase with pronoun, and I replace verb phrase with verb and S. That's a sentence. Okay? Verb, or it can be sentence. Notice that what is want? Want is a verb. The second thing is a verb. So that's why I have replaced VP with V or S. Okay. Now, so noun phrase is a pronoun, and this. Now, what is pronoun? Pronoun is I, and this is that particular terminal that we were talking about. So pronoun is I. So from start symbol I am able to reach the first word I. Fine. Now second word what I want is want, which is a verb. So verb phrase can be a verb and want is a verb. So I've got the second word also. Now to print bills.init file. So this sentence can be then further split as noun phrase and verb phrase. Now noun phrase, okay, is basically a pronoun because two. Now when I say I want two is a token. So there is also something called as, see, after tokenization there is a process called as stop word removal, which I have not spoken. Stop word removal is the one which removes the stop words. Stop words are frequently occurring words in English which individually does not have any meaning. For example, the or to, in, these kind of words, they, when they are used in a sentence, sentence gets a meaning, but when they are individually used, say the itself does not have a meaning. So after in morphological analysis, as I mentioned, there is something called as tokenization as a first pre-processing step. The second pre-processing step usually is called as stop word removal, wherein all these stop words are removed from the given sentence just to not waste time, right? So let us assume that to, this word to is already removed. Now next is print, correct? Now print is a verb. Okay, so verb phrase can be replaces verb and noun phrase. Now what is pronoun? I. Now verb, print is a verb, so I want, to is removed, print. Okay, noun phrase can be further split as adjective and noun phrase, and you know that uh, bills is an adjective. Similarly, noun phrase can be further split as adjectives and nouns. So noun phrase can be replaced with adjectives and nouns. Okay, so .init is an adjective and file is a noun. Okay, students, please note here noun phrase. Okay, noun phrase, instead of NP this should be N. Instead of NP noun phrase it should be N. So remember this. Okay, that's why NP can be replaced with N. So this is the part three at the end of the syntax analysis. Third step, so basically in the second step, that is syntax analysis, the flat structure, the text sentence which is a flat structure is converted into a graphical representation or a hierarchical structure called as a parse tree. Now third step or third component of NLP is semantic analysis, wherein we are talking about the meaning of the sentence. Okay, so the structure created by syntactic analyzer in the previous case, these structure are now assigned meanings. Okay, so the question comes when I say I means who? Want, what is the meaning of want? Right? Print, what is the meaning of print? So all this has to be told to the machine. Now this to map each of these words and to find the meanings, we can use one knowledge representation mechanism that we have already studied in unit 2, and that is called as frame structure. Okay, so mapping is made between the syntactic structures and the object in the task domain. So this is semantic analysis. So structure for which no such mapping is possible may be rejected. Example, suppose the sentence is colorless green ideas slip furiously. Now the problem here is colorless green ideas slip furiously. Syntactically this sentence may be correct because the syntax categories which I mentioned here, with respect to that the grammatical rules may be specified. But when you take the literal meaning of this sentence, colorless green, can a colorless be green? No. Green what? Ideas. But ideas can be green? No. Ideas slip furiously. Can ideas slip? And does anybody slip furiously? No. So although the according to the syntactic categories, this particular sentence fits to a syntax given by or specified by English, syntactically the sentence is correct, but with respect to meaning, semantically this sentence is wrong, and as a result it would be rejected. Okay, now semantic analysis must do two important things. One, it should map individual words into appropriate object in the knowledge base. So for this we are going to use that frame structure. And second, creation of correct structures to correspond the way the meanings of individual words can combine with each other. Now we can use frame based knowledge base that contains the units mentioned in the previous steps. For example, this is just an example. We have created a frame. Now user is a person whose login name, it must be a string. Now user 68 is one such user, so it's an instance of user whose login name is John. Now why this is important? Because I want to print bills file, correct? So I may be John, correct? Similarly user 73, okay, it is also instance of user, so is a person, and his login name is Bill, correct? So with this I can actually mean that user 68 is I, that means I who want to print the file, and user 73 is that person Bill whose file I want to print. Then F1 is an instance of file structure. So let's say F1 is a file structure, is an instance of file structure. An extension of that F1 is .init, and whose owner is user 73. Who is that user 73? His login name is Bill. So this is that file which I am talking about. Okay. Then file structure is basically what? It's an information object. When I say file structure is an information object, that means it could be a flat file, it could be index sequential file with respect to operating system information object, right? Then further continuation, printing. I want to print, no? So what is printing? Printing is a physical event where agent must be an animate or a program. The agent who is going to print, it could be an animate, that is a human, or it could be a program, and the object must be an information object. What is being printed? It must be an information object. So in the previous case I have told you that file structure is an information object and file F1 is an instance of file structure. So basically what can be printed? An information object can be printed. Similarly, wanting means what? What is the meaning of want? So wanting is a mental event. Agent for this wanting must be an animate. It cannot be a program. Program does not want. It is human who wants to print. An object must be a state or an event. Okay. Now commanding. I want to print, no? So what is commanding? Commanding is a mental event. The agent must be an animate, a human. Okay. Performer must be an animate or a program. Who performs it? It could be an animate, a human, or it could be a program that carries out this particular commanding. An object, it must be an event. Now, this system is an instance of a program, right? Now, RM1. So these are basically markers that I am using. RM1 is an instance of wanting. Okay. RM1 is basically the whole sentence. Okay. RM1 instance of wanting. So I want to do something, right? Agent is RM2 and object is RM3. Now what is RM2? I. What is RM3? A printing event. That is I printing bills.init file. So agent for this printing is RM2, which is I, and object for this printing event is RM4. RM4 is basically that bills.init file, no? So what is RM4? RM4 is an instance of file structure. Extension is .init and owner is RM5. Who is RM5? He is Bill. So RM5 is an instance of person whose first name is Bill. Okay. What you can do is just go through this particular frame structure once again after this video is over and try to figure out what exactly this frame structure means. So this kind of frame structure, when you write in a hierarchical fashion, it indeed gives meaning to each word, okay, which program can now understand. Okay, so as I've told you, in step number 3 we use syntax analysis, wherein a parser is determined, parser is designed. Then in step number step number 3, what we do is in semantic analysis we provide meaning for each of the term in the sentence. We provide meaning, we associate meaning using something like frame structures. Okay, and now the next step is, or next component is, discourse integration. The meaning of individual sentence may depend on the sentences that precede it, and it may influence the meaning of the sentences that follow it. Okay, for example, you consider this sentence, John wanted it. Consider the sentence, John wanted it. Now the word it in the sentence, what is it? It will depend on the prior discourse content. It will depend on the prior sentence, the sentence which was preceding this particular sentence. Okay, so this it depends on the previous sentence. It depends on the previous discourse content. While the word John may influence the meaning of the later sentences. Suppose after this there is a sentence, he always had ambition. Who is he? So this John may influence he. So whenever we consider in English, whenever the machine considers individual sentences, the individual sentence can be viewed like this: John wanted it, and it is difficult for machine to map what is it. But when you take the sentences together as a paragraph, then discourse integration is a technique wherein each of such words are mapped to the actual discourse based on the previous sentence or based on the next sentence. This is called a discourse integration, a very important step of NLP. And finally, the last step or component of NLP. Okay, before going to that, let's say if you have, okay, I'm sorry. The next component of NLP here, this is not discourse integration. It is called as pragmatic analysis. Okay, it's called as a pragmatic analysis. So it is not discourse integration, and this is not fourth step, this is a fifth step. Okay, so the fifth step here is called as pragmatic analysis. Now, fourth step is discourse integration. In fifth step here, the structure representing what was said is actually reinterpreted to determine what was actually meant. For example, if the sentence was, "Do you know what is the time?" So this should be interpreted as a request to be told time. So this is your pragmatic integration, pragmatic analysis. So this completes with the stages of NLP. Okay. In my next lecture, we are going to see in detail what is syntactic processing and what are the different types of parsing, how parsing are done, and finally we'll see bottom-up parsing approach. Thank you.